Hello, ladies and gentlemen. My name is Phoebe. I'm the Inside Sales Executive from Intel, and I will be your host today. In this session, we are going to invite Mr. Stephen Lin, who is the Marketing Director of Cyberlink, to present to you Cyberlink FaceMe Facial Recognition technology and how this technology is deployed in various smart IoT applications. Mr. Stephen has more than 18 years of marketing experience in IoT, ICT industry, covering consumer and commercial products. Stephen is specialized in demonstrating innovative technologies and how these technologies benefit industry and communities. Before we get started, we would like to bring your attention to Intel's notice and disclaimer as projected on the screen. We would also like to share with you Intel's Global Human Rights Principle. Without further ado, please join me to welcome our guest speaker, Mr. Stephen.
Thanks, Phoebe, for the introduction. In the following 20 minutes, I'll give you an introduction of Cyberlink, our FaceMe Facial Recognition SDK, and how our solution is optimized for Intel's IoT solutions. First of all, let me introduce myself. My name is Stephen. I'm the Marketing Director from Cyberlink. I've been with Cyberlink for almost 10 years. And currently, I'm located in Cyberlink's headquarters in Taipei, Taiwan. And I'm responsible for global marketing as well as the regional marketing in the APAC region, such as Taiwan, Singapore, and Malaysia, and other Southeast Asia countries. In today's presentation, we'll give you a quick walkthrough and introduction of my company, Cyberlink, and also introduce our FaceMe AI Facial Recognition SDK. Also, we will introduce how our SDK is optimized for Intel IoT technologies, such as OpenVINO, Movidius, and RealSense. To begin with, I'll give you a quick introduction of my company, Cyberlink. So Cyberlink is founded in year 1996. We are known as a multimedia company, and we're also very skillful in AI technologies. So most of the people knows us by our consumer multimedia software that actually we have shipped more than 600 million copies to end customers worldwide, including Power DVD, which is our flagship media player for playing DVDs, Blu-rays, or other media files on your PCs and notebook. And additionally, we're also having a wide range of media creativity software, such as Power Director, our video editing software, and Photo Director, our photo editing software. And we're also having tools like audio editing. And starting from year 2018, we are expanding our product line because in the past, we are already having a lot of experience in AI, in face, and AR, all this technology. So we decided to release and develop a new product, which is FaceMe AI Facial Recognition Engine. And right now, we are ranked as one of the best suppliers worldwide for the AI facial recognition technology. So we know in the past few years, facial recognition is everywhere and different type of IoT application. For example, in security, facial recognition can be used for surveillance system or for public safety use to find out the criminal person. And in the retail space, you can use facial recognition, like for example, to make your CRM system better, to be able to recognize a VIP walking to your store and providing the in-time help. And for digital signage, instead of playing the regular advertisements, it can actually help the digital signage deploy with segmented marketing. Like for example, for male or female or person at different ages, they can be pushed with different type of advertisements. And in terms of banking, we're seeing facial recognition is right now used for a lot of applications, like for example, cardless transactions or mobile bankings using face as your ID to use the banking services. And in home, you can use facial recognition on your PCs to log into your computer. You can also use that for like a smart doorbells. And in offices and factories, facial recognition usually will be used for accessing control, like entering the restricted area, time and attendance, or even like granting access to some restricted equipment in the factory. So FaceMe is a cross-platform XDK that we are known for the accuracy rate. We can provide up to 99.3% of accuracy rate. And additionally, it supports cross-platform from Windows, Linux, Android to iOS. And we know that Linux is having a lot of different distributions, so we can support like Red Hat, Ubuntu, CentOS, Yocto, or many different type of Linux distributions, depending on what the end deployment is like. And lastly, we know right now a lot of facial recognition applications are running in the cloud, and some are running in the edge. But our engine can be deployed both on the edge device or in the server. So for example, on the edge device, it can be an access control device, time and attendance device, or it can be a digital signage, or it can be a surveillance camera at the edge. While in the server side, it can use the facial features extracted from the edge to match the identity in the server to provide things like, for example, unlocking a door or keep time and attendance records. So that our biggest benefit is that the capability to run on both edge and server devices. And in terms of facial recognition, there's one of the most important benchmark worldwide. It's called NIST, NIST, National Institute of Standard and Technology in the US. And they are hosting a facial recognition vendor test, FRVT, which they renew the benchmark every few months. So in the NIST benchmark, there are several different categories. And two of the most important categories, including the visa border, 1/n, meaning that you are at the border and your face is being captured by the customs department, like with a webcam. So this picture is used to compare your identity within a database. Take this, for example, is 1.6 million faces database, and finding out what actually is the identity of this person. So this is called the visa border 1/n. And the other important category is called wild photo 1/1. So the wild photo means that this photo is taken in public spaces or open spaces, like mostly are from surveillance camera. So, you know, the video or photo being captured from surveillance camera usually are having more critical conditions, like for example, the lighting conditions, the resolution, and the faces are partially occluded, or even their faces are having different angles. So, in the real world for facial recognition, the wild testing is the most critical one because the face is not always staring to the camera. So, so the 1/1 wild photo test, meaning that I capture one person in the camera and comparing with the photo in the database, and to see if these two persons are the same. Okay, so in the latest NIST report, FaceMe is ranked high in both of 1/n and 1/1. So visa border 1/n, our recognition rate, our accuracy rate is 99.73, which is ranked as top 6 globally. And when excluding China or Russia vendors, that actually our ranking is number 1. And for wild photo 1/1, that our accuracy rate is at 96.98. So this is actually quite high, and it's also ranked 6 globally, and it's number 1 when excluding the China vendor. So some of the deployment which having the security concern and would like to choose like non-Chinese or non-Russian solutions, that we're actually the most trustworthy and the most accurate commercially available facial recognition supplier. So as mentioned earlier, that FaceMe is optimized for many Intel IoT technologies. So in terms of OS, as mentioned earlier, that we support Windows and Linux. And in terms of Intel hardware, we support OpenVINO toolkit, which is available on Intel Xeon processors, Core i processors, or some of the Celeron processors. Additionally, we also support the optimization for Intel Movidius vision processing unit, VPUs. And for some of the scenario which requiring to do anti-spoofing, like for example, banking and transaction, we also support Intel RealSense 3D depth camera, so that can verify if the people standing in front of the camera is a real person, or a person's face is being printed on a cardboard, or a person's video being played on a tablet PC. So our SDK can provide many different features, like for example, handle your video in and doing image preprocessing to enhance the quality, and can perform 2D or 3D anti-spoofing. And next, it can detect faces and extract facial features, and then manage a facial template database, and then doing one-by-one face match or one-by-n face search inside of the database. And for the developer, it doesn't matter that what kind of devices you want to develop. It can be servers or workstations, PCs or IPCs, surveillance cameras, or even like IoT edges, like for example, digital signage or post devices, that they can get the data from our SDK, and only porting the system layer and user interface, then they can build a solution which is powered by facial recognition. And how does FaceMe work? So first of all is that face detection is the very first step of facial recognition, that we can detect when people walking toward a camera and the face is showing on the video stream, that facial recognition like FaceMe can detect the face. Then next is facial recognition. So the way facial recognition works is that it can extract the facial features in a vector basis. Vector basis means that it will be a digitized number. Then this number can then be matching or comparing with all the face vector data, facial feature templates in the database to find out the actual identity of the person. And third is face attributes. So we can extract attributes like age, gender, or even mood. We can detect whether the people is happy, angry, sad, or surprised, or they're looking neutral. And also we can detect the head pose, like the heads up and the heads swing left, swing right. So like in the most useful use case is that right now it's a pandemic era. So a lot of the devices, like for example ATMs or kiosks, that you cannot use your hands to touch the touch screen, right? So you can use the head gesture to notify if the people is nodding or swinging hand, meaning it's yes or no. And image processing is that we are having a true theater technology, which actually was originally from our Power DVD media player, which can help enhance the quality for the video, like enhance the pool lighting, increase the resolution, etc. So this can also increase, pre-process the image and increase the recognition rate. And anti-spoofing in many of the scenarios, like for example banking, it can detect whether this is a real person or photo video attack. So we can support both 2D camera on regular notebook or mobile phone, or even 3D camera, like for example Intel RealSense, or other devices like iPhone or iPad, which have 3D structure-like cameras. And lastly, the most important is that the capability to detect the mask and to recognize a person when wearing mask. So we know that in the pandemic era that people needed to wear masks. So our SDK can provide two things. One is to verify if the person is wearing a mask or not. And the other is that even when wearing masks, we can provide more than 98% of the accuracy rate to verify the identity. Next, let me show you this video about FaceMe. So first of all, face detection. When people walking towards the camera, we can detect the face. And if you are tagging the person with a name, then the next time you walk in, you'll see it's the same person after comparing to database and showing it's the person's second visit. And additionally, as mentioned, that we can detect the facial attributes like age, gender, or emotions. So you can detect whether the person is a male or female, what's their age, and are they feeling happy or sad or angry. So this is very useful in a retail store, like for example, to verify like how many male or female customer coming to my store and what's their age and how they feel about my services or the experiences. And for the mask, we can verify both temperature and the mask wearing status and can verify the identity even when wearing mask. So for example, this lady doesn't wear a mask, so we can detect that. And if you're covering your face with your hands, can still detect it's a no mask. And of course, if your head having fever, then we can actually integrate with several brands of thermal camera to find the forehead temperature to notify if a person is having fever or not. And as for image preprocessing, our True Theater engine can do a few type of image enhancement like lighting, sharpen edge, or reduce the noise inside of your video, and also doing a resolution upscaling. So by applying a True Theater enhancement, it can increase the accuracy rate by 11.65%. So the FaceMe SDK is available in 3 different models: UH, ultra high precision, VH, very high precision, and Edge, high precision models. So the major difference between these 3 models are the requirement for the hardware. So UH, normally you need a more powerful system with GPU or VPUs like Intel Movidius. And while the Edge model is running on much lighter devices, like for example, with SoCs or lightweight chips. And in the middle, the Edge model can be installed and operated on regular PCs with powerful enough CPUs, like for example, the CPUs with OpenVINO. So it can run on PCs, notebook, industrial PCs, or AI boxes. So the other difference is that the model size, the UH has a larger model at the 300 mega, while VH is much smaller, only 17 mega. And the template size, VH is 3 KB in size. And you can see that on a CPU-only device, we actually recommend more on the VH model because it's lighter weight and the accuracy rate is pretty close to what the UH can provide, while it doesn't require such heavy performance in terms of system, means that it can be running on a lower cost device without the help of GPUs. And FaceMe is optimized for many Intel IoT technologies, such as OpenVINO. With the help of OpenVINO, we can provide 5.4 times performance for AI processing. Additionally, we also support optimization for Movidius, that with the help of a Movidius VPU, we can provide 17.4 times faster processing speed comparing to a CPU. And also for some scenario requiring anti-spoofing, that we can support Intel RealSense camera, which can provide 100% of spoofing attack. So in terms of frame rate, when OpenVINO is enabled, FaceMe can provide more than 5 times performance basing on the frame per second of image being processed. With OpenVINO on the 7th generation i7 CPU, it can process 23 frames per second, while if without OpenVINO, it can only process 4.5 frames per second. So the performance gain is significant. And additionally, in the latest edition for Intel CPU, the 11th generation Tiger Lake, which supports the VNNI instruction set, we can provide even better performance on both V-Edge and Edge models by providing more than 2 times of performance when VNNI is enabled. And additionally, as mentioned, that FaceMe is also optimized for Intel Movidius VPU. So Movidius VPU is available in many different form factors, like for example, the USB type that Intel is having the NECS2 in USB stick type of form factor. And also some of the suppliers are providing Movidius VPU in the form of mini PCIe card, so it can be installed on a very lightweight, small form factor industrial PC, like for example, those ones from Advantech or from IEI. And additionally, there are also like a PCI Express, a larger type of cards, which can allow developer to put multiple Movidius VPU on it. Like for example, both IEI and Advantech, they are having the Movidius card, which is equipped with 4 or 8 VPUs on a single card. So with the help of Movidius, we can boost the performance up to 70.4 times, and also saving the resource on the CPU. So here's an example. Then when running on a very entry-level Celeron CPU, you can see the original processing time is 4 milliseconds, 4,000 milliseconds, which means it's 4 seconds to process a single image. And the CPU usage is very high at 90%, even 100%. While when the device is installed with Movidius VPU, you can see actually the processing time is much smaller, only at 200 milliseconds, means 0.2 seconds. And the best yet is that the CPU usage will be much lower because the AI computation is running on the VPU only. So the CPU only use like 25 to 28%. So in terms of processing time, that the speed with Movidius VPU is 17.4%, and we are also getting 72% less CPU usage. So we are running this test on the Advantech industrial PCs. And additionally, as mentioned, that there are some Movidius cards coming with multiple VPUs. So take this one from IEI, for example, that on a single card with 4 VPUs, the performance can boost up to 3.6 times. And on a single card with 8 VPUs, the performance can be 6 times faster. And next, as we mentioned, that in some of the scenario, you will need to do anti-spoofing, this prevent the spoofing attack, like from a photo of a face or a video which is played on a tablet with your face. So we are supporting 2 types of anti-spoofing. The first one is to support the 3D depth sensing camera. So take Intel RealSense, for example. We can provide a true positive rate, meaning it can recognize being able to recognize this person is 98.2%, and the true negative rate, meaning the spoofing attack rate, meaning being able to verify if this is not a real person, then the true negative rate is 100%. So it's actually very nice because the depth sensing camera is facing on the depth map of a face. So if you're using a tablet or cardboard with the faces on it, that actually, because it's flat, so our engine is able to verify it's a fake face. However, in many of the deployment, there are not necessarily having the 3D depth camera. So we also provide another way to use 2D camera, like the camera on your phone or on your regular laptop, or even a regular webcam, to use the AI technology to verify if it's a real person or a fake person. So let's take a look at this video. So the anti-spoofing usually is using in the banking industry for the remote or e-banking service. So this is the Intel RealSense camera, And when a real person are walking towards the camera, you show it's a real person and this lady is a VIP. While if I'm using photo to attack the system, you show spoofing. This is a fake person. And how about having a face video play on an iPad, still show it's a fake one. Okay, so this is use a depth sensing camera. While this is another example of using regular 2D camera, we are having an AI algorithm to detect if this is a real person, or if I'm using a face printing on a cardboard, or using a facial video to attack the system, that we can use 2D camera to do the spoofing prevention. So that's all for my presentation today. I hope you enjoyed that. And if you're having further questions about FaceMe, you can come to our website at www.cyberlink.com/FaceMe or contact us through our sales representative email in different regions.
Thanks again, Stephen, for your time with us today.